Okay, for the first one, we want to graph the solution set. So we have this inequality here in two variables. And so the first part it wants us to look at is what's the boundary line. So our boundary line is just looking at the inequality, but as in equals. So we have 2x plus 5y equals 5. And it says, should it be dotted or solid? Well, it needs to be dotted because we don't want to actually equal. If you look at this, it says strictly greater than 5. We can't be equal. A solid line would mean we could actually equal that number 5. And so we're going to do a test point, but let's try and sketch the graph. So 2x plus 5y equals 5. I'm going to rewrite that in our nice form, which means y equals. So I'm going to move the 2x over. So I have 5y equals negative 2x plus 5 divided by 5. We're looking at y equals negative 2/5 x plus 1. So that would mean I have a y-intercept of 1, or I've shifted up 1, and my slope is that negative 2/5. So I'm going to go down 2 spaces over 1, 2, 3, 4, 5. And that's supposed to be a dotted line. Now, as long as I do not go through 0, 0, that's the test point that I like to use. And so I'm going to test 0, 0 in the original inequality, and I want to see if it's making a true statement. So again, 0, 0 is located right at the origin. If it's true, then I am going to end up shading everything down here. If it's not true, then I want to shade everywhere where that 0, 0 is not. So let's look. If I plug in a 0 here, that's 2 times 0. Plus 5 times 0, that 0 is greater than 5. That's false. So I do not want to shade where 0, 0 is. So that means I'm going to shade everywhere up above this line. All right, for number 2, we're going to graph the solution set again, but this time we have x squared plus y squared. Our boundary line is a circle. X squared plus y squared equals 9. Again, it's going to be dotted because of that less than. And when we see the 9 here, that means my radius is the square root of 9, which is 3. And my center, I have no shifting, is at 0, 0. So 0, 0 is my center. 1, 2, 3, 1, 2, 3, 1, 2, 3. And 1, 2, 3. So here's my circle. Again, dotted line because I don't want to actually include that line because otherwise those would be all the points where I actually equal 9. And so then I need to determine which way to shade. So again, let's pick a test point. So I'm going to test 0, 0, which is right in the middle. And I'm going to plug it into the original. So 0 squared plus 0 squared, is that less than 9? Is 0 less than 9? Yes, it is. So I'm going to shade everything inside the circle. And you can also kind of read this one. It says, when is the circle less than 9? Like having the radius is less than 9. So then you look at part A and B, they're saying, okay, well, what happens if we switch that inequality around? If we're greater than 9? Well, if that's happening, then we would shade outside the circle. And you could check with the test point. So if I plug in 0, 0, we should end up with something that is not true. Is 0 bigger than 9? No. So that would make us shade outside because we couldn't include that 0, 0. Now the only difference between A and B here is that we now would have that equal to line. And so then that would mean we'd have to have a solid line for our circle, for our boundary. So quick sketch, if we had this guy, we would shade everything outside for this picture. And if we had this guy, oh, he wouldn't be, this is what I mean, nice solid boundary, but it would still be greater, so we would still shade outside our circle. Okay, for number 3, so we want to graph now a system. So that's going to be looking for the overlap of these two. So we have 2 lines going on right here. So I'm going to rewrite them in our nicer form. And again, I'm looking at just the boundaries. 5y is equal to negative 2x plus 5. Dividing by 5 everywhere, we get y equals negative 2/5 x plus 1. So we know we're kind of decreasing. We're shifted up 1. Down 2/5. And what else? I want to make this line solid, which I know because I have that equal to. So I'm going to connect these nice and solid. And then I also want to think about my shading for just this first inequality. And I would like to, again, plug in 0, 0 and see if I get something true. So 0, 0 plugged into the original will be 2 times 0 plus 5 times 0. Is that less than or equal to 5? Is 0 less than or equal to 5? Yes. So I want to make sure I shade where 0, 0 is located, which is right there. So that would be everything down below the line. And so then I have to graph the next line. Again, we'll put it in that nice form. So I'm looking at negative 3x plus 4y equals 4. Add the 3x over. So I'm looking at 4y equals 3x plus 4. Dividing by 4, we get y equals 3/4 x plus 1. This is shifted up 1, so I'm at 1, and then it has a slope, positive slope, 1, 2, 3, 1, 2, 3, 4. And this is a solid line also. And I know that because of that equal to. And then I need to decide on my shading. I'm going to test 0, 0 into the original inequality. So negative 3 times 0 plus 4 times 0, is that greater than or equal to 4? Is 0 bigger than or equal to 4? No! So that means, since 0, 0 is located in that center point, I don't want to touch there. So I am only going to shade above the line here. And so you can see my intersection, this little triangular section here, it satisfies both the inequalities. So that's the part that I'd be talking about as my solution set. All right, let's look at number 4. Number 4, our boundaries here are circles. So we have x squared plus y squared equals 4. That's a circle at 0, 0 with a radius square root of 4, which is 2. So I'm going to sketch that. 0, 0, 1, 2, 2, 1, 2. And this is going to have a solid line because of the equal to. So there's my graph. And now I need to know if I should shade in or out of that. So if I test 0, 0, let's see if that's true. Is 0 squared plus 0 squared greater than or equal to 4? Is 0 bigger than or equal to 4? No. So I don't want to shade inside. I'm going to shade everything outside of my circle. And again, to solve a system, I'm going to graph the other inequality as well, and I'm going to see where the intersection is with this solution set. So all this blue stuff is all the points that will satisfy the very first equation. So let's see what's going on with the second equation. That's going to be x squared plus y squared equals 16. This time we are dotted compared to the solid line that we just drew. And that's a circle at 0, 0 with radius square root of 16, which is 4. So at 0, 0, we're going to go up 4, right 4, down 4, and left 4. And that's a dotted line. And this time it says, you can read it that it says less than, but I could also test 0, 0, and I'll have 0 squared plus 0 squared. Is that less than 16? Yes, it is. So I would want to shade where 0, 0 was, which would be inside that circle. So inside the green circle, you can see that's the whole solution set. And so then the overlap is actually making that little donut here. That's the solution set. That's the overlap between the two sets. All right, and this last one, number 5, this is again a system. So we need to satisfy all of the inequalities. In this case, we have 3 inequalities. So the first boundary is y equals x squared minus 2. That's a parabola shifted down 2 spaces. No stretching or shrinking. I know it's going to be a solid line. So I'm going to draw that. And again, I don't touch 0, 0, so let's test 0, 0 to see if I'm going to shade inside or outside of that parabola. So 0, 0 would be 0 is greater than or equal to 0 squared minus 2. Is 0 bigger than or equal to negative 2? Yes. So I'm going to have to shade where 0, 0 is. So here's 0, 0. I'm going to have to shade that hole inside my parabola section. Okay, and then I have another one. I have y is equal to x. That's my next boundary. This time it's dotted. And this is actually our identity. It has a y-intercept of 0 and goes up 1 over 1. But you guys should recognize that as the identity equation, the diagonal line. And we just said dotted. Pretend it's nice and straight. Let's do a test point again. But this time we can't do 0, 0. How about 0, 5? We can't do 0, 0 because it's actually on the graph. So let's test 0, 5. So that's saying our y value is 5 is bigger than 0. Yep, that's true. So that would mean we'd want to shade where 0, 5 is located. So 0, 5 is located right here. So we want to shade up above our line. And you can see the overlap right now inside the parabola above the line. So we have one more section, and that's looking at y equals 4, and that's going to be solid. It's a horizontal line, solid. And this one we could just read. It says y is less than that line, which is everything below. So I'm going to shade everything below that. And so hopefully you can see that overlap in there. The overlapping section is this little part right here in the middle. So we're above the blue line, below the green line, and inside our parabola. And that's our solution set.